Well, I am Michael Hastings. Thank you for making it. This is my final project presentation for C projects. Just a little bit of background, kind of a little resume. I had a summer internship at Micron, Denver, which is it's just a company that does engineering. They build machines that put together products for the customer who decides the machine. I can't go into too much detail. I have about 13 years of just experience with just general engineering and technology. From a very young age, I was finding like board games, a pinball machine I had when I was really young. I'd rip it apart and find out how it works. I've taken 3 years worth of technology classes here at Grandview. I've taken the tech drawing, which is mostly about 3D CAD software. And then after that, I took advanced engineering design, engineering design, which is another one going farther into 3D CAD software. And then advanced engineering design, which was a kind of miniature version of this class, where we made our own product. We took an RC car and modified it in such a way that it improved it or made it different. And that kind of helps with this class overall. My advisor list consists of my expert advisor, Sean Flanagan, and I sadly could not be here today because he is in Ireland, I think, for Micron. He is the controls group manager for Micron for Denver. He's the one who decides who does the coding on each project. So if there's a new project that comes out that needs someone to do code for them, he decides who's the one who does the code. If they have questions, they go to him. He has the authority to rewrite the code from the ground up if he needs to, which helps with this because my project is a lot of code that I didn't have a lot of experience in, and he helped me get the groundworks and what I should do for that coding. My support advisors consist of Kane Bruce. He's my local code expert. He knows code very well. He can translate what I want the computer to do into the code that I need to write for it and help me understand what the code does. Adam Powell, he's an Arduino expert for me. He knows Arduino boards pretty well. He also has taken this class before, so I know to go to him if I have any questions on the process of the class or what I need to do for a certain due date. And then Noah Tawada, he's my hardware expert. He knows a lot about the inner workings of how like switches and buttons work, and how he's also proficient with the Arduino boards that helps me run my project. So my inspiration for this project is just, first of all, computers. Every day you're using a computer of some sort, whether it's your phone, your desktop computer, a TV. It's in our lives so prevalently, and I wanted to learn more about how they're made, why it takes so long for them to develop and like evolve the way they do. And the progression of technology kind of goes along with that. As you can see here, like the way phones have progressed, I want to see how that's done, and I kind of learned that through my project, just how from the very groundworks, the beginning sketches, the idea to the final product, how that comes and transforms is a big part of why I wanted to do this project. So my project, on the most watered down basic level, is to get an Arduino board to function as a very basic computer. An Arduino board is a microprocessor that's used to control servos, to read resistances, to make a very basic computer. And in order to do that, I had to go through a lot of research that I'll get to, and the process took a lot of time for me to learn, and going back, it would have taken me 2 weeks to do it if I had all the information that I had to research. So my project objectives, first one was to become adept at Arduino programming. That way, if I wanted to, if I had a project idea, I could take an Arduino board, apply it to the project, and be done, and not have to spend months upon months researching how an Arduino board works. Learn aspects of designing computers and interfaces. That was the main part of my project, was learning how to make an interface and how to make that work with my own hardware that I made. Learn about computer input and output programming. That's where I press a button, it gives the Arduino board an input, and then it spits numbers back out at me, or it does what I told it to. Learning the CNC machine or 3D printing. I made a case for the computer, and I had both of those up there because I wasn't sure which one I wanted to take. The CNC machine would have been way too difficult and convoluted. I went with 3D printing because it worked really well, and it was a quick process that I could replicate if I needed to. And my last objective was to learn how Arduino boards will interact with the custom input panel, which actually kind of ties back into the Arduino programming, because that's all it is. I need to make it, define which button is which button in the code, and then the board just interacts with the input panel. So my goals for the project was to program our Arduino board to function as a computer. Sorry about that. Which I did get to work. I had to input it to where it displays to a computer rather than its own screen because time constraints. The input-output system of the functions to where I press a button, it gives me a number back. The functions is where I press a button and it actually calculates something, or it'll actually open an application, which is the biggest part of my project. Command and response system, very similar, where I give it a command and it responds. That's more akin to the functions than it is the inputs and outputs. And my last goal was to be able to program it outside of the IDE, which is the development environment where you program the Arduino boards. I did not achieve that because I didn't have enough time to. However, I didn't need to because it's very easy to edit the code. It was easier than I was anticipating. I was expecting it to be a long process where I'd have to open the application, go search through the code. It's much easier than that. So my company logo, Alutech, ALU stands for Arithmetic Logic Unit, which is just a processor. That's the core of all computers, the CPU in your computer. And that's basically what the Arduino board is. That's why I decided to go with that name. The colors are very striking. It's bold. The design there with the red stripe holding up that part of the T there also goes with how my technology experience supports the project and helps me dedicate more time and energy into the code and learning how it works. So my final outcomes, what I achieved, a functioning Arduino computer. I got it. It's done. It works. It's at my table if you want to talk to me after the presentation. I wanted to make a guidebook for the computer. However, I didn't get around to it. I just didn't have enough time, and when I thought about how I would have to make that guidebook, it would have taken more time than it's worth than to just explain it. And then I wanted to have a small computer demo. I have it at my table. I could not get one working for this just because it's too rudimentary and it's not worth the time, because I'm going to explain everything it does here, I think, pretty thoroughly, so I don't need to have a demo of it on the presentation. So the technology I had to learn was the Arduino IDE, how to program an Arduino board, how to interface with it. I had to learn SolidWorks. I didn't really have to learn it as much as I just had to use it to design the case, and I had to learn MakerBot so I could 3D print the case. SRP Player was a program we used for the CNC machines, which I ended up scrapping because I decided not to use those. So my project timeline. In October, I had to get together all the stuff to make the input panel, all the buttons and wires, which my friend Noah supplied to me. Thank you, Noah. I had to make the panel, which involved learning how to solder again, and then inputting the wires to where they're connected to the Arduino board, which was just a process that took time. I didn't really have to learn too much there. In the blue is the things that I added to my timeline, which was, because those 2 steps was the original timeline, and it was very, very quick. It didn't take long at all. I thought it was going to take long. So on the 16th, I ended up making a menu, which I moved from later in the timeline. So it will actually begin to where I press a button, it will navigate up and down through the menu. I had to continue that on the 19th, and then make it to where I hit a button, I press the enter button, and it'll actually bring up a window. And over fall break, I finalized the menu system, but I was prepared to refine it. So I got it to where it was very rudimentary and it worked, but it didn't work well. So in November, at the end of October to the beginning of November, I started making functions for the calculator to activate, which at that step was just I press a button and it pops up a window saying you press the button, and it told me that I was pressing the right button. And then in November 13th, I added in to where I was creating more inputs because I only had like 3 at that point, and I wanted to make 9 because I wanted a 3x3 grid system. And then I also made the buttons actually navigate that entire grid because previously all I had to do was go left and right. So I had to add a component to it. On the 15th to the 21st, I made the navigation system and further refined it to where it was more clean. Previously, I had to make it to where if I wanted to go down, you'd see it go to other squares before it actually went down. That was a problem with my wiring. I found out later, but at this point, I thought it was a problem with my code. And then on the 28th, I finalized the navigation system, and I began coding a way to make the inputs activate functions. So instead of just me pressing a button and saying, hey, you press the button, I made it to where I press the button and it actually opened an application. And then November to the beginning of December, I just completed the selection system. That way I could start adding inputs into it. December was a very short month on the scale of the project. All I did was do the mid-year presentations because my mid-year was a little bit long for what it needed to be, and I had to condense a lot of information into it. In January, I was supposed to finish my presentation and then begin making more functions for the window activation system. I finished my presentation, but I couldn't make any more functions on the 9th, just because that's just what time constraints give to me. On the 12th to the 22nd, for that 10-day span, I was making functions for the system to activate. I think at that point I began designing the calculator that I implemented into it. Just fleshing out the system and making it more like a computer instead of just a test bed. And then January 24th to the 26th was our mid-year presentations, so I could really bring that down. And then 30th to the 5th, that is in white because I didn't actually have to change that. I just designed a case for the Arduino and then printed it. That's all I had to do. It wasn't that hard. So by the mid-year, I had a button panel. I learned how arrays and invoke commands worked, which was what allowed me to navigate the menu system to where when I pressed up, it went up. It pressed down, it goes down. I made the Arduino and Visual Studio communicate because I used Visual Studio to communicate with my Arduino board because I didn't have enough time to get my own separate screen, so I made an application, a function that adds the screen to display to. Visual Studio displays which buttons pressed. That can be seen right here. I was on button 1 and I pressed right, which corresponds with number 6, and it moves over here and it's reading that I pressed number 6, which is more of a debug thing. That way I can make sure when I press the button, it's reading the right thing. And if it's not, I can see when it's reading to try to rewire it or rewrite the code how I need to. And then I had a functional navigation and selection system, which you can see in the navigation, like I said, I press right, read 6, it moves right. And the selection system at that point had worked. So for February, I had to actually make the case and the containment unit, which is printing it, milling, handling, those should be highlighted in red, but that was an oversight on my end, because I didn't end up doing that, I just printed it and it worked. And I had to put the assembly in it, the Arduino board with the buttons that I made. On the 15th, I had started testing the code and hardware capabilities or compatibilities. So I was just going through and stress testing it, seeing how many times I could press a button, or if it would start to not work right if I pressed a button too many times, or if I could make multiple windows pop up at once, which I didn't want to do, and it did not, so that's good. On the 21st to the March 15th, I wanted to continue fixing the issues, but I didn't end up doing that because there was a lot of problems with my wiring, which I hadn't figured out yet. I still thought it was a code issue. So I was fixing the issues, but it was a temporary solution because I was fixing an issue that shouldn't be a problem in the code. And then February 21st to March 15th, I ended up actually fixing the physical problems along with the code problems because the case had an issue where it printed without the right constraints, so my buttons wouldn't actually fit. So I just took a Dremel and rounded the holes out a little bit more and it fit. But then I had to fix the soldering because my buttons, some of them weren't soldered correctly to the wires, so it wasn't getting a signal. So when I pressed a button, it wasn't doing what it was supposed to. And that's how I ended up fixing the issues that arose. So in March and April, I wanted to finalize the computer itself and then finish my presentation, design my table, practice the presentation. That's how I'm here. But I did have to finalize the code for the calculator and compile it. That way it was an executable, that way I could actually open it through my menu system. And then I linked the calculator and the menu together, that way they work with each other. Also in this time under finalization, I just updated the GUI, that way it wasn't a white background with blue squares and it matched the color scheme of everything else that it had with the red and black. So my final progress was that I had a printed and modified case. You can see it there deconstructed with the top plate, the front plate off, and the board with the buttons in it. I had created the basic calculator, which that is an early test of the basic calculator. And then I eventually fixed my hardware issues, which I think this picture was taken after I fixed them. And then I made applications open and close one another, which this is the menu right here as it is now. And you can see there's a calculator and a notepad. The rest of these are unbound because I have nothing that they actually activate. But the calculator, like I said, I eventually updated it to where it looks like this with the color scheme and the design. And then Notepad is a system or a program that comes with most computers pre-installed, so you can open text files and edit documents, which is important because I can integrate any executable I want into my menu, and it doesn't have to be something that I custom build. So for my research, I had to research Arduino programming because I still wasn't sure exactly how it interacted with the hardware of my computer. I had to research how 3D printing worked, which just turns out I had to make a 3D model and save it as a different file, so that didn't require much research. It was probably about 15 minutes. Arduino hardware interactions was further how the buttons that I made would interact with a computer and an actual application that I designed. And that's where most of my time came in for my research. So for serial communication, that's getting my board to plug into the computer and talk to it. And that's just one type of serial port. That's the VGI cables that monitors plug into computers. It's on every computer. And it works very similarly to a lock in my situation, where one side of it will open, the data will be received in, it will close, and then the next end will open, and then take out the information that it needs. Which is important to realize, because when I first tried it, I just tried to have both ends open, and if it does that, the code just doesn't work. It will throw an error, and it won't let you do it. And after researching, I figured out that I had to make it to where it opens one end, you get the code, it closes that end, and then the other end opens and takes the code out. I also had to research Visual Studio. This was just something completely new to me. I did not know how to design an application. I didn't understand exactly how I would make it work, but I had to research how to, this is just a very grainy screenshot of Visual Studio, and that's what the programming looks like when I'm opening the programming. You have all your code here, and you have the libraries and stuff over on this side. Up here is one tab, and then over here would be another tab of mine where I have the actual physical design of the application. The actual design of the application wasn't that hard. It's just click and drag. You have a little toolbox, you put a button down, you can resize it however you want. But with the code, it's a little bit more difficult because I had to get it to where it will read the serial port, which I wasn't sure how to do it at first. And I had to look up how the Arduino writes the serial ports to get them to cooperate. That way they're both trying to read the same language. I also had to research how invoking and multi-threading works. So how that works is you have separate threads in your code, like one for executing, reading the serial port, and the other one for actually doing something like that. And here you can kind of see an example where both threads start, and then this one does its progress, and at the same time it sends a message down here to the second thread. And then once it finishes its process, it sends a message over to the first thread saying, hey, you can do your part now. They both continue down until it gets to the end. It says, now it's your turn, and they both continue on until the function is done. Without that, at first I didn't know how this worked, I didn't even need it. So I tried to hit a button, and it would do nothing. It would start the process, but then when it got to the point where it needed to send a message to the second thread saying it's your turn, it wouldn't send the message, and it would just crash the program. Because it would try to move to the next step, but it couldn't because the code wouldn't run. The last thing I had to research was arrays, which I use for my grid-based navigation, which is how when I press the right button, it moves right. So here's just a horizontal array where it's at 0, and these values aren't exactly accurate, but it's at 0, and if I press right, it adds 1 to that value, putting it over in this section. And then here you can see this is vertical where I press down, it adds 1 to that. Now I made it to where it's a 3x3 grid, so it's just this combined with that towards 9 buttons. It's a very basic system, and I can expand on it very easily, which is important in my code. I also had to research how buttons clicks works. Here's a screenshot of just, I pressed the button, went out and highlighted button 5, and it says I did it, button 5 out of 9, which is just my debugging, making sure that when I press buttons, it opens what I want it to. And then here's just a screenshot, it just click me, and it's highlighted because it's been clicked. It says the button's clicked. That was a short step in the process because all I have to do is just make it to where in my code it says if button 1 is clicked, open screen that says you did it, and then put an OK button on it, that way you can close it. And then with those button clicks, I made it eventually to where instead of popping up a menu, I click the button and it opens an application, which is how I get it to switch between my menu to a calculator to Notepad. So I had some pitfalls, which like I said earlier, the soldering and grounding of wires. When I first made the button board, I didn't realize that I needed to ground the wires to make sure that the current would flow the direction it needs to. And the soldering, like I said, certain wires weren't soldered to the right button, so when I pressed a button, it wouldn't do what I wanted it to. And And I also had problems with certain wires just being outright broken on the inside, so I couldn't tell that they were broken, because when you try to test it and put current through it doesn't work unless you get the connections on the inside of the wire to physically touch each other, and then you'll get a very weak signal. Another pitfall I had, which was my main problem with the research and the project, was just code translation, which my friend Kane helped me with a lot, is that code is its own separate language. So when you're trying to tell it to open an application, you can't just type in open the application. You have to tell it to search for it and then execute it and then make sure it's running. And he helped me do that. He's also the one who pointed me in the right directions with the invoking and the multi-threading stuff. I'd ask him, hey, how would I get it to where if I press this button, it gives me a window? He'd like, you'd use this function right here, and then I'd look it up, and he'd explain to me what's happening because he'd had much more experience with code, which helped accelerate the process a lot, so I didn't have to go myself try to understand what each word meant in the code. While my bibliography is going, does anybody have any questions about my project? No.
If you were to add additional functionality to this, what would it be?
I could add an Excel spreadsheet that I make myself. I could make it open in Word. I can make it to where I just open Excel spreadsheet and edit it using the board that I made, because the way I made it, it can interact with applications. It doesn't have to be a custom-made application specifically for the board. Lucas?
So you said that like the number of functions are extensible, like you can add more, but isn't the hardware limited to, don't you only have 9 buttons?
Yes, but I can add it to where I can move it to where in the menu, if I press like the button at the bottom right, it'll move to the next, it'll close that screen, open a new one that has more functions on it, and I can go back and forth between those. Adam?
So you said it could open any program you already had on your computer. So if you had a program, say like Tetris, could you play Tetris with your controller? I
could. It would be a matter of making it to where Tetris will read the controller and will actually recognize what I'm pressing as a function. But I can open Tetris. As it stands, I can open Tetris and then play it through the computer, not my Arduino.
Okay.
Any other questions?
Okay, thank you.
Good job.